Assalamualaikum. Today we are going to present our group project for Dynamics. First of all, I would like to introduce our group members. My name is Sitra Hafiza.
My name is Nohanis Fana.
My name is Adrian Shuhada.
My name is Alia Shazana.
My name is Abdul Aziz Mukris.
Okay, next. Now, I will explain the introduction of this group project. Dynamics is a branch of mechanics concerned with rigid bodies and deals with the forces. It is the study of the causes of motion and changes in motion. Thus, it is involving primarily Newton's laws of motion. Dynamics is very important for analyzing systems consisting of single bodies or multiple bodies interacting with each other. Other than that, dynamics allow the movement of objects to be predicted under the influence of different forces such as gravity. In addition, it can also be used to predict the movement of planets in the solar system. Or another example is the time it takes for a car to brake until it stops. Therefore, there is nothing in this world that can be analyzed without using the concept of dynamics. It also consists of two distinct parts, which is kinematics and kinetics. Kinematics is the branch of mechanics concerned with the motion of objects, which is used to relate displacement, velocity, acceleration, and time without reference to the forces which cause the motion. It is also describing the motion of objects using words, diagrams, numbers, graphs, and equations. The goal of any kinematic study is to develop sophisticated mental models that serve to describe the motion of real-world objects. If there is no kinematics in life, no one will know the motion of the earth around the sun. In simple terms, kinematics describes how the motion is happening. Kinematics also has different types of motion, which is vertical motion, horizontal motion, and projectile motion. Real-life example of kinematics is a stone hitting the ground. Besides, kinetics is the study of bodies with reference to the force which causes the motion. It is the study of the relationship between the forces acting on a body, the mass of the body, and the motion of the body. Real-life example of kinetics is how the enzyme affects the rate of biochemical reactions, torque, and friction. In a nutshell, we anonymously chose kinematic as the topic of our case study, and the title of our case study is Rotation Motion about Fixed Axis. Next. Okay, our objective of this group for this group project is first to find acceleration, velocity, and displacement of the boxes. Second, to determine the rotation around a fixed axis of a rigid body. And last, provide the computation, figure, or theory. Next.
Okay, for the case study description. In this study, we look at the kinematic and kinetic of rigid body in relation to the motion of a moving object at a specific speed. Kinematic is the relationship between a body's change in motion and the force that causes change, where kinetic is the relationship between a body's change in motion and the force that causes the change. In this case, our rigid body is the movement or motion of gear with load. Gears are used in rotary motion to transfer kinetic energy using levers. For every tooth on a gear can be thought of as the lever that can be used to generate mechanical advantage in a system. A gear system has a driver, which is the gear that is power, and the driven, which is the gear that is moved. The rotary motion is reversed when the two engage. Gears serve many purposes. In this section, we will look at gears that increase or decrease angular velocity, while simultaneously decreasing or increasing torque as the energy is conserved. Gears in rotating system function similarly to levers in translating system. So here the picture of gear. Next.
For the calculation, analysis, and evaluation, referring to case study, two gears are arranged. Assuming gear A has a constant acceleration of 35 rad per second and initial angular velocity of 8 rad per second. To find acceleration, velocity and displacement of the box C in time in 5 seconds. Motion of gear A. As it can be seen, gear A is rotating with uniform angular acceleration. To find the angular acceleration from gear A, given initial angular velocity equal to 8 rad per second, acceleration equal to 3.5 rad per second, and time is 5 seconds. By using a velocity angular formula, initial angular velocity plus acceleration times time is get 8 plus 3.5 times 5, we get 25.5 rad per second. To find theta equal to initial angular velocity times time plus 12 t square. 8 times 5 plus 12 times 3.5 times 5 square. We get 25.5 rad per second. Next. Motion of gear B. Next, gear B is rotating with uniform angular acceleration. Gear B is coupled to gear A. V equal to RAWA equal to RBWB. 0.5 times 25.5 equal to 0.6 WB. WB we get 21.25 rad per second. Acceleration equal to RA times acceleration A equal to RB times acceleration B. 0.5 times 3.5 equal to 0.6 acceleration B. Acceleration B we get 2.917 rad per second. Motion of box C. To calculate the motion of the box, as can be seen, box C is coupled to gear B. Since gear B has uniform angular acceleration, box C will perform a rectilinear translation motion. Using velocity equal to RW, V velocity C equal to RWB equal 0.250 times 21.05. We get 5.2625 meter per second. Acceleration equal to RC times acceleration B, 0.250 times 2.917, we get 0.7291 meter per second square. So for the SC equal to R theta B, 0.250 times 69.791, we get 2.43 meter. Next.
After that is discussion. When a rigid object rotates about a fixed axis, every part of the object has the same angular speed and the same angular acceleration. Fixed axis rotation describes the rotation around a fixed axis of a rigid body. It is an object that does not deform as it moves. There's show how to apply all the ideas we have developed up to this point about translation motion to an object rotating around a fixed axis. The most important terms that we should know about rotating motion in fixed axis are angular position, angular displacement, angular velocity, and angular acceleration. Angular position is the found right move in a circular path for different end of theta. The position of the object will be different. Angular displacement is the change in angular position of the body during its motion. Angular velocity is the angle at which the body turns in a certain time. Other than that, angular acceleration is the rate of change of an angular velocity with respect to time of the angular acceleration of the body. At last, we also can conclude how the rotational quantities, theta, angular velocity, angular acceleration, and times are related to one another.
Next, for conclusion, Using our understanding from this investigation, we can clearly and precisely explain the calculation, figure and theory. We also can evaluate the problem using Newton's law and the theory of rigid body kinematics. A single force can also be split into two forces that act at right angles to one another using this technique. In this project, we can compute regardless of what external forces or moment are applied to a rigid body. The distance between any 2 points on it remains constant. Generally, a rigid body is thought of having a constant distribution of mass. That's all from our group. Thank you.